Thank you for taking the time to view our video on reducing loan risk using data analytics. Our group included Kenji, Vinky, and Tim. Let's examine the business understanding aspect of our project. Our group chose to look at lending data from the Lending Club to see if we could solve the business problem of maximizing profit, improving over the existing Lending Club application process. After a loan's approved, Lending Club makes a profit provided that the loan applicant repays both the loan's principal and interest. Less money is made when the borrower defaults before paying the entire loan. Our group classified these loans as charged off. Loan data from 2007 through the third quarter of 2017 was available from the website, and it was broken into 11 different sets. We found that each set of data was a little different, which complicated analysis. We wanted to see if we could find predictive models that might have the ability to improve Lending Club's profit and see if we could find interesting relationships in our data sets. If we were to continue data mining iterations, these relationships would be the basis to further improve increasingly accurate predictive models. If we could find a way to make the loan process less risky by predicting more loans that might be charged off, we could maximize the profit of Lending Club. Understanding our data. There was a great deal to figure out before we began to create a model. First, we wanted to note that we were looking at loans that had already been through Lending Club's risk mitigation model, so our results were dependent on their models pre-screening the loans and assigning interest rates based on the loan applicant's submitted application. It made sense to us to only look at loans that were made before 2015 because there were a large number of loans in these sets that had no final status. Hence, we would only have been able to evaluate the short-term loans in these data sets. Doing so would have biased our model by not being representative of the entire set of loans for each year. There were 151 variables in the data sets we were looking at in this time period. And looking at the 2015 data, we found that 14% of the loans had been charged off, worth $245 million. So if we could find ways to avoid these losses, we hope to have a significant portion of this amount considered as profit for us. Data prep. For this step, we spent a considerable amount of time examining missing values, outliers, combining multiple categorical values into only relevant values. To make things easier for analysis with our analytical tool, we combined all data sets into one jump file. Manipulating this data set was sluggish due to the large number of records, so we chose a subset of approximately 54,000 random records. We integrated 9 different types of loan status into 2 options of 0 and 1 for our target variable of charge-offs. This involved removing records that did not match these statuses. We examined histograms, correlation charts, did bivariate analysis, and finally looked at the log worth values to reduce our independent variables to 25 from the original 151. After setting up a 60% training and 40% validation split, we were left with a number of records shown in the slide. Modeling. We evaluated 3 models: logistical regression, classification trees, and neural networks. Our predictive model would produce confusion matrices that would show us how often we guessed whether a loan was charged off versus whether they were actually charged off. Here are a few important observations. First, sensitivity corresponded to bad loans that were correctly rejected. Specificity referred to the percentage of good loans that were correctly accepted. To evaluate based on profit, we looked at the average cost in 2014 of a failed loan and compared it to the profit of a good loan. The cost of a failed loan was $6,100 on average, and the profit of a good loan was $2,500 on average. In observing our results, the most accurate and useful model appears to be the neural networks model. Evaluating results. How did we do? Based on profit, we evaluated the models we had created, and the best profit was associated with the neural networks model. which would have saved about rounded up to $500,000. The logistical model did fairly well on an estimated savings of rounded to $445,000. The tree model actually lost over $3 million. Important observations of our modeling results included: our models generally break even on short-term loans. Our models discovered that there was a much better profit on long-term loans. And we wanted to note that the results weren't final. As more and more of the loans matured, the numbers on the slide only represented a conservative estimate of profit. And finally, the neural network is verified as the best performing model based on profit. Evaluating patterns. Although the logistical regression numbers were not as accurate as the neural networks model, their associated log worths bring some interesting insights into the loan data. On this side, you can see the amount that each independent variable contributed to the logistical regression model. Unlike the black box aspect of the neural networks model, here you can get a good idea of which variables and to what extent they contributed to the predictive model. Looking at the top rated variables, we see longer terms had a higher chance of being charged off, but also had higher profit. Interest rates corresponded to charge-offs, and this would be expected since loan applications would be paying more based on the risk of their credit application. The number of trades opened in the last 24 hours and the debt-to-income ratio similarly correlated to a higher number of charge-offs, and the extent can be seen in the log worth graph on the slide. Although not shown on this slide, the sign of these terms in the logarithmic equation shows whether the contribution is negative or positive. Some surprises were found when we finished up this project. When we reduced the data set from 151 to 25 variables, we were surprised that a number of the variables shown here ended up not being useful in our predictive models. For example, we believed the purpose of the loan might have some correlation to charge-offs, but based on our analysis, it ended up not being statistically significant. Data mining is an iterative process, and we successfully developed a model that might possibly improve future LendingClub loan decisions. We also wanted to look at what lessons we had learned and what we might do if this project had been funded to do a second data mining cycle. First, we would consider treating short-term loans differently from long-term loans, since these loans behave very differently, with very different cost functions impacting profit. Next, we would want to consider predicting payment percentage rather than charge-offs, since most charge-offs had some percentage of the money paid back. Hence, not all charge-offs were complete write-offs. Next, we would want to look at ways to make the models more conservative by raising a threshold for rejecting charge-offs. Next, we would want to consider ensemble models that could be found by combining our existing and possible other models. We could look at unions, intersections, or perhaps a majority rule combination of our solution sets. Finally, we could evaluate our predictive models against other data sets that were public, as well as start looking at the more recent loan data from the LendingClub to see if we continue to have an improvement over their existing loans. Thank you for taking the time to watch our presentation. We hope you found it both informative and enjoyable.